Hello, everybody, and welcome to our lesson on chapter 19, which is about applications of integrals. And we're going to start with section 19a, which is about the area under a curve. So remember from the end of chapter 18 that we can find the area under a curve between two boundary points, okay, using a definite integral, okay? So that's an integral that has an upper bound and a lower bound that we're taking of a function. And if we were to take the integral of this function between these 2 points, we would find the area under the curve. Now, if we want to actually calculate this, we use what's called the fundamental theorem of calculus, which says that if I take the integral and evaluate it at b, and I take the integral and evaluate it at a, and I subtract them, then I should get the value of this integral, this definite integral. And so, for example, if we wanted to find the area of the region enclosed by this line, y equals 2x, the x-axis, and the line where x equals 4, then we could find it in 2 ways. Okay, well, since we know how to draw this picture and we see that it makes a triangle shape, we could just find the area geometrically, meaning find the area of 1/2 base times height. The base here is 4, and the height is the value of y when x equals 4, which is 8. So 1/2 times 4 times 8 gives me 16 units squared. I could also, so just verifying that this integration method works, I could take the integral of 2x between when x equals 4 and x equals 0. Okay, or I should really say between when x equals 0 and when x equals 4. So the integral of 2x is x squared over 2. Remember that when I divide by 2 and then I multiply by this 2, I'll be left with just x squared. And I want to evaluate that when x is 4 and when x is 0 and subtract those values. In both cases, I get 16 units squared. Now, we're going to learn how to do this using the GDC, but I'm going to skip those examples for now, and I'll come back to that in a later video. I'm not sure if we'll have a chance to talk about it this year in particular. Let's take a look at another example. If I wanted to find the area of the region enclosed by y equals x squared plus 1, the x-axis, x equals 1 and x equals 2. Well, so I've got my curve, y equals x squared plus 1. I've got the value, the x-axis is right here, so that's the upper part of my area is defined by this curve. The lower part's defined by the x-axis. And we're finding the parts between when x equals 1, which is this vertical line here, and x equals 2. So I need to take the integral of x squared plus 1 dx between 1 and 2. Well, the integral of x squared plus 1 is x cubed over 3 plus x, and I need to evaluate it at 2 and 1. We use these big square brackets to indicate that I'm evaluating. So I'm going to plug in 2 where I see x first, then I'm going to plug in 1 where I see x, and I'm going to subtract those two values. Remember to use the brackets here to help you remember that you're not just subtracting this term, you're subtracting everything in the brackets. When I evaluate it, I get 8/3 plus 2 minus 1/3 minus 1. And simplifying, I get 10 over 3 units squared. So this green area here is 10 over 3 units squared. Has an area, I should say, of 10 over 3 units squared. Okay, and we can do that not just with quadratic or linear functions, but also with trigonometric functions. So it helps to draw a picture here. So remember that y equals sine x would look like this. Y equals 2 sine x would have a period of just pi, so it would do this whole cycle in just pi units. So the area under the first arch has boundaries when x equals 0 and x equals pi over 2. We know that the height of this function is 1, okay? But all we really care about are these x values. We want the area between this curve and the x-axis between when x equals 0 and pi over 2. So I can take the integral of sine 2x dx between pi over 2 and 0. The integral of sine 2x is negative cos 2x times 1/2. Okay, because remember, I would have to have taken the, if I took the derivative of this, I would get negative sine 2x times 2, so I'd have to divide that out. And then I evaluate it when x is pi over 2 and when x is 0. Okay, I end up with negative 1/2 times negative 1. and negative 1/2 times 1. Remember that this means 2 times the value of x, so that can cancel.